Okay, so this video is just going to be for page 10 since it's work, force, and displacement problems. So I just want to do this page by itself before we get to power. So hopefully this will kind of help you out if you're stuck on some practice problems. So the first problem says calculate the amount of work done by the appropriate agent in each of the following cases. So A, it says a workman exerts a horizontal force of 30 newtons to push a 12 kilogram table across a level floor a distance of 4 meters. Okay, so remember, work equals force times distance. Now, I'm not lifting anything, I'm just sliding it across the floor. So that really means that mass does not do anything. If I was lifting the table, then mass would actually matter, and then gravity would matter as well. So all I have to do basically here is take my force. Okay, so work equals my force, which is 30 newtons, and my distance is 4 meters. Okay, so this one's just as simple as that. Okay, so just multiply those two and you get an answer of 120 joules. Okay, so again, remember, if we're not lifting it, mass doesn't really matter. So B, a horse pulls a sled 12 meters along the ground at a constant speed of 2.0 meters per second at a frictional force of 1,500 newtons. Okay, so now we kind of talked about this is when you're at constant speed, it means you're not accelerating. So that would mean net force would equal out to 0. Okay, which means your net work would be 0 as well. But here we're not actually talking about net force. We want to figure out what work is being done by the horse in this instance by itself. Okay, so a horse pulls a sled 12 meters. Okay, so there's your distance. Okay, along the ground at a constant speed of 2.0 meters per second. There's a velocity, but in this case, I'm probably not going to need this. Okay, but I'll label it against a frictional force of 1,500 newtons. Okay, so that is actually, so he's having to overcome that 1,500 newtons to keep pulling. Okay, so that is your force. So work equals force times distance. So work equals force, which is 1,500 newtons, times my distance, which is going to be 12 meters. Okay, multiply those two out, and that would come out to 18,000 joules. Okay, man exerts a force of 150 newtons. Okay, there's your force of the parallel to a slope to slide a 50 kilogram mass 8 meters up the slope. Okay, so again, we're not actually lifting this, even though it's kind of going up a ramp. Okay, we're not actually lifting it up. Okay, so this means our force is 150, and then mass doesn't really matter in this case. So, and my distance would be 8.0 meters. Okay, so work equals force, which is 150, times distance, which would be 8.0. Multiply those out, and you get 1,200 joules. Okay, a 1.6 kilogram block is lifted vertically. Okay, so again, lifted now. So that means mass does matter. Okay, so that's your mass, and that means gravity is going to be a factor now. At a constant speed of 1.2 meters per second, so velocity is not going to really do me any good. Okay, now velocity would probably make more sense if it talked about an initial velocity, a final velocity. Then we could probably use those things. But if we only have one velocity, it's not going to really do much for us. Okay, and it lifts through a height of 20 meters. So there is your distance right there. Okay, so remember, if we're lifting something, force equals mass times gravity. So that's the same thing as saying work equals mass times gravity times distance. So mass would be 1.6 kilograms, gravity would be 9.8, okay, and your distance would be 20 meters. So multiply all those out, and you get 314 joules. Okay, E, a girl pushes a skateboard forward with a thrust of 120 newtons against the frictional force of the sidewalk of 40 newtons while moving 2.5 meters. Okay, so again, we're just finding how much work is being done by the girl. I know the sidewalk is going against it, but we want to figure out how much work is the girl actually doing. Okay, so I'm going to do, her force will be 120 newtons. Okay, I'm not really asking about the sidewalk, so that's not going to really affect me there. And while moving 2.5 meters. Okay, so there's her distance. So we have our force and our distance. Okay, so work equals force would be 120 times distance would be 2.5. Okay, so 120 times 2.5 would be 300 joules. Now, if we did ask for something like network, then we could look at the frictional force of 40 newtons times that same distance and figure out what the difference would be. But in this case, we just wanted to know what was the work being done by the agent performing the work. Okay, number 2, from what height must a 10 kilogram hammer fall in order to do 240 joules of work? So again, since it's falling, that means gravity matters, so mass does matter, so there's our mass. Okay, to do 240 joules of work, so I actually gave you work right there, on a stake being driven into the ground. Hint, the gravitational force must first do 240 joules of work on the hammer. So in this case, I actually know my work, 240 joules. I know my mass, which would be 10 kilograms. Okay, and falling, so gravity is a factor. So we want to know from what height. So that means distance is your question mark. Okay, so we're going to plug it in. So work is 240 equals mass times gravity times distance. So mass would be 10. Gravity would be 9.8. And distance or height we don't know. So I'm going to leave that as D. Okay, so I'm going to solve for D. I'm going to divide both sides by whatever 10 times 9.8 is, which is 98. So divide both sides by 98. That means it has to have a height of 2.45 meters. Okay, number 3, calculate the amount of work done in each of the following. A gardener pushes down on the handle of a lawnmower at an angle of 45 degrees. So there's your angle. With an applied force of 141 newtons. So there's your hypotenuse force, while pushing the mower 8.5 meters along the ground. Okay, so again, I'm going to kind of draw this out. You have your triangle. So I'm pushing down at an angle of 45 degrees. Okay, my force on the hypotenuse is 141. Okay, I'm not going to use that. I'm going to use it basically to find out what is my force going in the horizontal direction, or your F of X. So remember, anytime we have an angle, basically work equals force times cosine of your angle times distance. Okay, because it's the same thing every single time. Okay, so I'm going to plug in my force is 141 times cosine of 45 times my distance, which is 8.5. Multiply all that out, make sure you're in degree mode, and you get 848 joules. Okay. B, a 40 kilogram girl skates is swung through one revolution in a horizontal circle at the end of a 10-meter rope. Okay, held by a stationary buoy at the center of the circle. The rope has a tension of 50 newtons. So if you notice, okay, you've got a circle here. Okay, it's being swung around. The force would be 50 newtons. Okay, but your force and your distance are going in different directions. You have one force is going towards the center, and then your distance is going perpendicular to that. So when your force and distance are perpendicular, okay, that means there is no work being done. Okay, so that was page 10. Hopefully that helped out a little bit.